Projectile motion. A simple example of motion in a plane. So, what is a projectile? Let us take an example to understand what is a projectile. When this cannon is fired, then the cannonball moves along this curved path. If there was no gravity, then the cannonball will have moved in a straight line, and if there was no initial velocity, then it would have directly fallen vertically downwards. Since there is some initial velocity and gravity is actually working, so this will be the actual path of the projectile. So we can define a projectile as simply anything thrown with initial speed such that it moves along a curved path under effect of gravity is termed as a projectile. How about we play a game to understand the physics behind projectile motion? In this game, there are two tanks. They are destined to attack each other. Let me be the first player and some annoying talkative student be my target and be the second player. So, the angle of inclination I have selected is 30 degree, and the power here will define the initial speed. Let us set it up to around 70. Changing the weapon, I would usually prefer chalks, but Roman candle is fine. Okay, that is a miss. Now, seems that changing the initial speed will bring the attack closer to the target. So, changing the power to 60 and firing away, and it's a hit. Now, applying our understanding of the physics, if we draw the origin at the position of the first tank and follow the path of the projectile, then the initial velocity of projection was directed along this arrow. So, when the particle moves from A to B, when it is fired at an angle theta with the x-axis, we have initial velocity u. When initial velocity is resolved into vectors ux and uy, then at any point the acceleration will be acting downward, that will be acceleration due to gravity. Now, ux will be equals to u cos theta, because since the angle theta along with the x-axis, so the x component will be the cos component. So, uy will be u sin theta. Since we have established that acceleration is only due to gravity, so horizontal component of acceleration will be 0, since gravity acts only vertically downward, and ay, that will be acceleration due to gravity along the y-axis, will be equals to minus g, as gravity acts in the negative y-axis. Now, for horizontal motion, if the velocity at any given point is v, then it again can be resolved into components vx and vy. Then we will have the first equation of motion, vx equals to ux plus at. Since we have already established ux equals to u cos theta, and since ax is 0, then vx will be nothing but u cos theta. Also, x will be equals to uxt plus 1 half axt square, our second equation of motion, and that will be nothing but ut cos theta. Since axt is 0, this entire term is 0, ux is u cos theta. So, x at any given point, distance covered along the x-axis, is given by ut cos theta. Similarly, for vertical motion, we can write the three equations of motion as vy equals to uy minus gt, y equals to uyt minus half gt square, and vy square equals to uy square minus 2gy. At all places here we can substitute uy equals to u sin theta. Now, magnitude of velocity at any given point will be equals to under root of Vx square plus Vy square. But we have Vx equals to u cos theta and Vy equals to uy minus gt. So we substitute them. We get magnitude of velocity equals to square root of u cos theta the whole square plus uy is nothing but u sin theta. So u sin theta minus gt the whole square. Simplifying it, we get u square cos square theta plus, this is of the form a minus b the whole square. So a square minus 2ab plus b square. Now definitely u square cos square theta plus u square sin square theta is nothing but u square. Hence the magnitude of velocity at any given point is found out by the expression square root of u square minus 2u gt sin theta plus g square t square. Similarly, the angle of inclination at any point is given by tan alpha equals to Vy upon Vx. So using these two equations, you can find velocity of the particle at any given point if you know the initial velocity of projection and the angle of inclination and what time duration has already elapsed. Also you can find the angle of inclination that is at the given point with the x-axis. Tune in for the next video to find expressions for maximum height, the range and the time taken to go from the point A to the point B.